Hi, welcome to the probability interview question number 2. So let's take question first. If you roll a fair-sided die twice, so we have been given a one die which we need to roll 2 times, and this die is a fair-sided. So every single possible outcomes are equally probable. So individual, let's say outcomes will be somewhere around 1, 2, 3, 4, 5, 6, because there is a 6 side of in one die, and if you just roll this thing, there is equally probable that all value will come. So that's why this is a fair sided die, and we need to roll this thing 2 times. So in a first possible outcomes will be, when you roll the first time, it can be from 1 to 6, and in the second time also it can be 1 to 6, because both the events are completely independent. So these are become our total possible outcome. Now what we need to find, what is the probability of getting at least 1. So when you roll a first time, it should be at least 1. That should be of our favorable condition. Or if you roll a second time, it should be at least 1 5. Or it can be a 5 in a both the roll, either in a first one or in a second roll. So our objective here is to find the probability of getting at least 1 5. So I have just for the demonstration, I have listed the 2 die. So let's say we'll first roll this thing, and we'll get the possible outcome 1 to 6. And if you roll the second same die the second time, you get the first to 6. As per the probability, we need to find the total possible combination. So let's do the total possible combination. Now how many total possible combinations are there? So as per the rules of multiplication, it can occur like a 1 1, or you can say 1 2, 1 3, 1 4, 1 5, 1 6. Same way 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. So there are total 6 ways the first outcome will come, and another 6 way second outcome will come. So we have a total 36 possible outcome, and that is nothing but if we roll the fair sided die 2 times. So there are total 36 possible outcomes. Now how does 36 come? Let's just simulate from Python code. So let's first roll the first one, and I'll just iterate through this range function. So range will go from first to 7. In the same way, we'll iterate for the second one. We'll find the total possible combination. So range from 1 to 7. 7 has been excluded. And let me just print number 1 comma number 2. So you can see that all possible combination will be in a first trial you may get 1, and then second trial you may get again 1. So either it can be 1 1, 1 2, 1 3, this way. So let me just make one counter set how many possible total combination are there, how many total possible combinations are there. So I'll just make count is equal to count plus 1. Okay, and we'll just print this count at the end of the program. So I'll just print CNT. So you can see there are total 36 possible combination may be possible. Now out of this 36 possible combination, we need to find only those favorable condition where we are getting at least 1 5. So if you observe this all possible combination in this 1 5, so in a second time we got a 5, so this we should take into account. This 2 5 we should take into account, 3 5 because it has at least 1, then a 4 5. In case of 5, we'll get 5 5. So in a both the case, we'll get a 5 in a both the roll. So that also we need to take into consideration. Again 5 1, 5 2, 5 3, 5 4 also will take, because in this case the very first rolling also we got 5. So at least 1 5. Then the last one is 5 6. So if you just manually count it, you will get around I guess 1, then 2, 4, 5, 6, 7, 8, 9, 10 and 11. So you'll get 11. So let's just simulate it from this code only. We'll just apply the same condition here. Instead of count, let's make it like a favorable counts based on our condition. So I'll just make another if, and inside the if loop we'll make one or condition, that either number 1 is equal to 5, then only you will count it, and the second one will become number 2 is equal to 5, then only you make increment. I'll just print it again, and we have here favorable count based on our condition. So you can see that whenever it iterates, it will just check for whether number 1 is equal to 5 or number 2 is equal to 5. At least one of them is 5, then only we'll make an incremental count, so that we'll get to know about idea that what are the favorable possible condition based on the condition has been given in a question, that what is the probability of getting at least 1 5. So let's just execute it. So we have executed successfully. Now we have total 11 possible combination. That was we have earlier counted manually. So we have total 11 possible combination based on the condition. Okay, so we got the total possible outcomes and we got the favorable outcomes. Based on the rules of probability, out of all possible combination, how many times your favorable occurs? So we have total 11 times the favorable occurs. So informally just I am writing 11 divided by total possible combination, which is nothing but a 36. So this condition relates to our favorable condition because that is what the probability we need to find. And if you are rolling the fair sided dice 2 times, that means that is our total possible combination of output, that is nothing but the 36. So the final output will become 11 divided by 36. So let me just print P. So we have total 0.3 is the probability. So 0.3 is the probability of getting at least 1 5 if you roll this dice 2 times, 1 by 1, and both of these events are independent. So that's all about this video. In the next video we'll see more probability related question, and see you into next video.